Ladies and gentlemen, please welcome Associate Partner for IBM Security Data and Application Security Services, Anatoly Bodner, and Senior Offering Manager for IBM Security Application Security on Cloud, Eitan Worcel.
Hi, everyone. Thank you for joining us. The session today will be about DevOps and application security, and security in general, how to tie those together. So I'll start by introducing ourselves. My name is Eitan Worcel. I'm the Senior Offering Manager of Application Security on Cloud. And with me today,
I'm Anatoly Bodner. I'm the Associate Partner for IBM's Application Security Services practice. Thank you, everyone, for coming over here.
So what is this about? In this session, we will share our strategy on how to integrate application security with DevOps. This strategy will be very thorough. We may be missing a couple of items that you guys can think of. But I want to make sure that no one is alarmed by the amount of effort and amount of practices and tools that we will have there, because it's really aimed for the mature, where you want to go once you complete your onboarding of the security. Each one of you should pick the areas, the best practices, and the tools that they want to focus on. And the way that we will do this session, Anatoly, who has the expertise from the services side, will start on the best practices, and then he will pass it to me to focus on the testing tools and the testing activities. And at the end, we probably won't have time for a Q&A, but there are 4 think tanks behind you, and we will go into more details there. Each think tank has another session, and of course, you can ask us following that session. So, Anatoly, please start.
Eitan, thank you very much. Thank you, everyone, for joining us. I know the weather outside is absolutely beautiful, so it's a big attest to you being here. We're very grateful for that. So this talk is around securing DevOps. Now, for those of you who may not know what DevOps is it's a novel approach to developing applications when time to market is essential, when time to market is critical. And DevOps really focuses around 3 main pillars. It is transparency, collaboration, and a great deal of automation between the teams involved. And in a traditional DevOps model, the teams that are involved are development, QA, and operations. Now, organizations that implement DevOps get to enjoy things like shorter development cycles, faster development time, faster time to market, improved quality, reduced costs, and reduced defects. And our objective in this talk is to share with each and every one of you here today with us, as well as each and every one of you watching this broadcast, some of the best practices that we recommend to have implemented in order to securely design, build, and run your applications using the DevOps model in the DevOps context, which means fast. Now, this happens to have a name, and that name is DevSecOps. And DevSecOps is the art of integrating and interlacing critical security processes within your development cycles, within your development process. And it is also the art of shifting security to the left by empowering each and every role within the development process with the skills, capabilities, knowledge, and tooling that they need to be able to fulfill their role successfully. That includes all the way up from business analysts to project managers to UI, UX specialists, developers, testers, operation, and engineering. Now, by shifting the responsibility for security to the left, you start building accountability in the development process for security. And when you start building accountability within the development process, some of the things that occur, one of the primary things that occur, is that decisions are no longer driven by convenience, but decisions for security are now driven by outcomes. Now, why do we care about application security? We know developers know how to code well. We know testers know how to test well. Why are we even having this discussion? Well, the reality is, in 2017, over 40% of cyber attacks that resulted in data breaches targeted applications. 40%. Now, some of you may say, well, that's probably because there's legacy applications, or maybe they didn't do the right level of testing on those applications. Well, that may be the case in many situations, but the reality is that roughly a quarter, this is important, roughly a quarter of security issues and security defects that are identified in traditional pre-production security testing still make it to the release, right? This is an incredible number. A fourth of all the defects in the security arena that are identified in applications statistically still make it into production. Now, why is that? There are several reasons. First is expertise. Do the developers have the right level of expertise to actually implement security controls properly? Do they have the expertise necessary to remediate security issues and vulnerabilities when they are given a list of findings from their testing outcomes? The other driver for this is time to market. Business puts a lot of pressure on development organizations to deliver, and deliver fast. If you are behind schedule, you have a big target painted on your back. That's just the reality of the development world. And the third is cost. Development projects have a budget. If you go over that budget, there are repercussions. So unfortunately, at times decisions are made to allow certain things past the gate just to make sure that you're still on time, you're still on target, both from the budgetary perspectives and the time perspectives. Now, how much cost do organizations incur by addressing application security weaknesses and vulnerabilities? There was an interesting study. This study was done several years ago by IBM's System Sciences Institute. And for those of you that may be in development or in QA testing, you'll probably attest that these numbers are fairly accurate. But the study measured the relative cost of addressing a security defect, a security vulnerability, relative to the cost that would have been incurred had this control or had this specific vulnerability been addressed earlier in the development cycle. And the results are staggering. You have upwards of 100% or 100 times higher cost of fixing a defect in release, so in an application that's already been released, than had that defect never made or never introduced into the code to begin with. Now, for things that are identified in testing, which is the pre-production phase, you have a drastic decrease right away. And subsequent to that, if you identify an issue in development, you're lower yet. So you can see very clearly that when you make that shift to the left, when you make an investment into your development organization, and when you empower the roles that are involved with the skills, the tools, the knowledge that they need to actually develop applications securely, the organization generally tends to reap the benefits of that. Now, it's also estimated that over half of security defects that are identified can be addressed at the development level. This is huge, right? If we're looking at statistics and we're looking at the fact that 24% of vulnerabilities that are identified pre-production still make it into live applications, knowing full well that we can get rid of over half of these very early in the development cycle, as an organization, it is our responsibility to make every effort that we can, put forth every effort that we can to do so. So at this point, we have a fairly good baseline. We understand why this is important. We understand what this talk is about. We understand our objectives. How do we get there? We have assembled a list of essential requirements, call them ingredients, call them components, that every organization must have in place in order to ensure systematic ability to design, build, and run applications securely. Now, we will cover, there's a lot of information up there. There are a lot of points up there. But what's important to understand is that if you're an organization that does development, there's a very good likelihood that you have most, if not all, of these processes already. The fundamental difference between just having it in place and how it's applied in the context of DevOps or DevSecOps is who does it, when is it done. In terms of when things are done, our objective with DevSecOps is move things to the left as much as possible. So we've identified the critical activities, the critical components that are necessary to ensure that applications are designed, built, and run successfully. Now let's take those items and let's start going and pushing them to the left, pushing that responsibility as early as possible in the development cycle. Can this be addressed during design? Can this be addressed during development? Can this be addressed during testing? And when you do that, you have a reference model which you can follow, which effectively will reduce the vulnerabilities that are identified later on in the development processes, leading to a reduction in risk, leading to improvements in productivity and improvements in quality. Now, you feel free to take a photo of this if you'd like. Now, I know these slides are also going to be distributed subsequent, and this talk is going to be made available. And we would love you to reference this. This is very good. This is very useful information. So now let's start going down step by step, or ingredient by ingredient. The first is having a secure SDLC defined. If something is not defined, if something is not documented, it's not enforceable. But having a secure SDLC defined is only half of the battle. The other half of the battle is making sure that all the processes that you have identified in your SDLC that are pertinent to security are actually something the organization can execute on. And not only can they execute it, but also can they scale it at the speed, at the scale that needs to be in tune with the development goals and objectives. Next item is training. This is something that is probably one of the best investments an organization can make in helping ensure secure development, secure design of software. When it comes to training, we oftentimes see organizations take the path of least resistance and getting some very basic awareness training, rolling it out and saying, yes, we do train. That's not enough. That's not sufficient. If we want to truly shift security to the left, we need to ensure that our project managers and business analysts understand the fundamentals of application security architecture. Make sure our developers not only are aware of common weaks and vulnerabilities, but receive training specifically tailored to the development languages and the platforms that they are coding in. We want to make sure our QA testers understand how penetration testers do their job so that when QA testing occurs, they can do their level of testing at a greater level of detail. Also, two very important aspects of training is track completion. Make sure you understand who completes, how long they take to complete, and also, extremely important, don't ignore poor performers. If you are tracking completion of training efforts and you have quizzes or tester validation methods, and you see that there's a group of developers or there are individual developers that aren't doing a good job, that aren't absorbing curriculum as they should, provide secondary training, because the reality is that if this is not aligned, if this is not addressed, those gaps in skills, knowledge, and capabilities will directly impact the end product. Requirements management. For anyone in development, you probably have heard of non-functional and functional requirements. Generally, the business comes up with functional requirements which dictate how the application should look, what it should do, what colors are going to be in the application, what are the fields, forms, buttons, etc. The non-functional requirements are requirements that are in the back end, that are under the hood, that power the way that the applications do things, the way they talk to databases, the way they handle data, the way they handle transactions and sessions, etc. Typically, security requirements management is a process that takes anywhere from days to weeks. Now, that's not exactly compatible with our mission of DevOps, where we want to have very, very fast development. But now, what makes DevOps possible is there's tooling that actually enables you to automate these processes, reducing those cycle times, for example, in requirements management, reducing that from days and weeks down to just minutes or hours. And when you can do that systematically, you can scale your development efforts without a compromise in security. Threat modeling. Who here has heard about threat modeling? Good, quite a few hands, fantastic. Threat modeling is an absolutely essential practice in developing secure applications, period. There is a concept called threat-driven application architecture, and threat-driven application architecture is the principle of understanding where is the application going, what environment, who's going to be using it, what type of data is it going to be handling, and then decomposing the applications into functional pieces to understand where and how can these applications be attacked preemptively. And designing and building security controls into your applications from the very design, from the very development, to ensure that when these applications whether it be in a mobile application or a web service or a very complex client-server application. Understanding how and where it could be attacked helps you understand what security components and what security controls and architectures it needs to have in order to defend itself when it actually goes out and lives in the real world. Implementation remediation support. We see a lot of organizations taking advantage of this. Consider this being help desk for your development organization. When your developers, who are great, smart, experienced developers, but when your developers have a question, what do? When they don't know how to implement a specific security control, or if they don't know how to implement or how to fix a specific security vulnerability that was found, what do? Well, typically, they'll either go and find code online or find examples or Google for a solution. Well, that's great, except for the fact that that also introduces potentially vulnerable code into your environment, one. Second, it also introduces an opportunity for developers to take existing code that may or may not work, put it in the forum, and seek a solution, which they probably will find. But what does that do to the organization? What is the level of risk that this introduces into the organization? So the concept of having available implementation and remediation support for both security controls and security findings is a very, very popular thing, simply because of the fact that it is the help desk for developers. Those that don't know how to solve a particular challenge, whether it's a challenge in design, whether it's a challenge in implementation, or whether it's a challenge in fixing an issue, can go back and speak to an application security subject matter expert who can provide them the guidance they need how to architect a solution, how to code a solution. A lot of organizations are building this internally as a capability. Some use an external party for this. But at the end of the day, this capability empowers the developers to actually have a solution and use a solution that has been reviewed, that has been vetted, that has been approved for the organization, rather than going out and actually grabbing something off the web. Now, before I hand it off to Eitan, I did also want to talk about test case alignment. We spoke a couple of slides ago about requirements management, which now can be automated. Test case alignment is the art of actually making sure that for every single requirement that goes into building your application, we have a corresponding test case, whether it be a unit test case, system case, end-to-end test case, whatever it is. But traditionally, organizations do this really well for functional requirements. However, for non-functional requirements, which is where the majority of security requirements come into play, test cases that are built out for testing and making sure that those controls, those non-functional controls have been implemented properly, are generally lacking. And when you have that kind of a situation, the very critical controls that are responsible for ensuring the confidentiality, integrity, and availability of your application that you're building and the data of those applications could potentially be impacted if it's not tested properly. Now, with the same type of tooling that I've discussed before for requirements management, there's great automation capability in test cases as well. So the very same tooling can generate your requirements, both functional and non-functional security requirements, generate the corresponding test cases automatically, get all that information implemented or imported right into your application lifecycle management solutions, making this entire process seamless. Now, this technology didn't exist 5, 10 years ago. That's why DevOps wasn't really possible maybe 10 years ago, or at least not to the same extent that it is right now. So now, at this point in the presentation, I will pass it over to Eitan to talk about some of the more advanced capabilities around testing, which is equally as critical as making sure we build right. Eitan?
Thank you. Thank you, Anatoly. Poodle, shell shock, heartbleed, Apache struts. I guess you heard about those, right? Raise hand, anyone? Something sounds familiar. You lost some sleep because of those, maybe. Open source libraries are heavily used in your applications. In fact, I would bet that there is no one real application in your organization that doesn't leverage open source libraries in it. You simply can't write commercial code without it. In fact, most of the code that is executed in your application, you never wrote those. Now, those buzzwords, those names that I just mentioned earlier, really significant vulnerabilities happened there, right? And they were in your applications. When your applications were outside, you need to test your applications to make sure that you don't have open source libraries with known vulnerabilities in them. It may be a surprise for some of you here or some of you at home who are watching us. When you are doing static analysis security testing, it doesn't check for open source known vulnerabilities. It's a different technology, and you need to use that technology. When do you need to use it? You need to use it in development stages, whether your developer from the IDE will run those scans as part of their build, but it doesn't end there. You need to make sure, you need to monitor your applications, the applications that are out there in production, in maintenance mode. You need to make sure that they don't have vulnerabilities that come from open source. And the reason is, as I mentioned just a second ago, I mean, Apache Struts vulnerability came out after those applications were live outside for many years with that open source library. So monitor those applications all the time. Oh, I missed a slide. Static application security testing. This is the next technology that I want to talk about. So there are two main approaches on how to do static application security testing, SAST. One is doing pattern matching. Regular expression runs on your application code and identifies vulnerable patterns. The second one, more interesting, is doing trace analysis. It takes the application code, identifies how the data flows in your application, all the entry points of the application, all the methods in between until it lands in the final location, which can be the file system or a database or an HTTP request. And the goal is to identify places, to identify traces of data where the data is not being sanitized, and by that flagging it as a vulnerability. Most consider this as the most suitable for the developers because it runs on the application code, it identifies vulnerability, and it points to the place in the code, to the line of code exactly where the vulnerability is identified, and often where you need to fix it also. But there are two main problems with this technology. The first one, I'm sure everyone knows here. This technology is notorious for generating a lot of noise, a lot of false positive. It will report for any finding that it found, even if that finding is completely unexploitable. And this is pain. What happens in most cases is that an expert, either a security expert or a dev champion, will go over the results, will filter, trim them down, and bring it to a developer. Or sometimes a services team from a vendor will do that. That takes time. That means that this technology cannot be used as part of DevOps if there is no solution for it. The second problem is less known. In order for SAST to be valuable, it needs to understand the entire application. Seems obvious, right? It needs to be able to understand each part of the code there. But as I mentioned just the previous slide, the one that I skipped, most of the code in your application and is actually executed is not your code. It's the open source libraries. So you have a lot of API calls in your application code, and the scanner engine needs to know how those API calls work, how all those methods works in order to be able to follow them. What vendors are doing usually, they will train the scanners on all those frameworks, and every time there is a new version, they will need to train the scanner again and again. And the problem here is that your developers are early adopters. They want to use the latest and greatest, especially if the previous slide, if the open source library that they were using is vulnerable, so they need to upgrade to the next version. The scanner may be behind, may not be able to scan the application now, or parts of the application are going to be outside of the coverage. When you go and shop for a vendor, when you are looking for a static SAST solution, ask your vendor, how are you going to cope with those two problems that Eitan now mentioned? Third technology that I want to talk about is dynamic application security testing, also known as DAST. High level, DAST runs on running application. It scans the running application, interact with it, it crawls the application, identify a lot of pages, parameters, cookies, and then at the second stage, it exploit. It runs tests. It actually attacks the application with all sorts of payloads and analyzes the response it gets from the application server to identify vulnerabilities. This is the most mature of the three that I mentioned now. But again, we have problems here. In order for a scanner to be able to scan the application, it needs to first log into the application. Login may be complicated. After logging in, during the scan, it needs to make sure that it's still in session, because an attack on SQL injection, for example, may result in the application kicking you out of session, so it needs to make sure that you're still in session. And one of the bigger problems is an application has a lot of forms in it. You need to form, for example, this bank account wants to transfer money to this bank account. As smart as the scanner can be, it depends on real valid user input. This is why many consider dynamic application security testing is not fit for DevOps. This, and of course, the fact that a dust scan can take hours, days, and even more than a week. But in fact, we already proved that, and some other vendors also already proved that dust can be part of the automated process, that a build can invoke a dust scan, and we can discuss about it later. This is my 3 ingredients for application security testing. In order for an application security testing to be used and valuable in DevOps, it needs to have those 3. Integration, because we want the developers, as Anatoly mentioned, we want the developers to take ownership and to work with their tools. Speed makes sense for everyone, of course, and coverage. We are not reducing the coverage in order to meet the developers' expectations. And this is a point. Integration is not just a plugin. My user is not Eclipse. My user is not Jenkins. My user is the developer, right? So we need to speak at the language of the developer. We want to integrate with the developers, not with the tools themselves. I know it sounds philosophical, but you need to understand where it's going. I'm not saying no for integrations, but they need to make sense. So as a developer, and I have years of experience in development also, what would I understand, right? I'm working, I'm using my Eclipse to write code, but I may have memory issues in my code. I'm losing memory somewhere. So I can use a plugin to help me to write a more efficient code. Plugin for efficient code? Maybe a plugin that will help me run a more secured code. So I'm not coming, as a security person, I won't come to the developer and tell him, use this plugin to run scans. I'm telling him, use this plugin to help you write a more secured code. Now, when I write a code and I enter a defect, QA may find that defect, or someone who runs automation may find a defect, and usually, if I don't fix it immediately, they will open a defect in a DTS, in a defect tracking system. There are no security vulnerabilities. There are security defects, if you want to talk with developers. So if I have a security defect, I will open it in Jira, for example, in a defect tracking system. Again, same integration, but the mindset has to change. Now, most mature organizations have regression testing, using functional testing, using Selenium, for example. Just mentioned earlier, dynamic scanning, dynamic application security testing runs against a running application. If I have a running application and I have a functional testing already operated and maintained, I'm going to leverage that to do dynamic application security testing. Of course, all of it, in order for it to work, it needs to be part of your CI/CD. It needs to run every day, every week, every month, a couple of times a day. Really depends on your model. So it needs to be orchestrated with, for example, Jenkins. Here are just a sample of our integration, but it is crucial that when a vendor comes and gives you integration, don't expect the plugin to work out of the box to your needs. You need to know that those plugins, those integrations can be extended. You need to make sure there is a REST API that can be extended, whether by the customer or by vendor. Make sure the fact that you have a plugin in the marketplace doesn't mean that you can use it out of the box. And I'm going to speed. Now, when you talk about speed, when you consider speed, the first thing that you would ask, how fast does it take the scan to complete, right? It's very important, but it doesn't end there. Speed, from my perspective, has at least 3 points. The first one I just mentioned, but the second one is, how long will it take to resolve this vulnerability, right? So that depends also on the complexity of the vulnerability, the complexity of fixing that new defect, and the amount of work. Sometimes the vendors can help you actually simplify the fixing itself, which sounds a bit strange. And the third, and this is very important, and again, not considered a lot, how fast can the vendor, can the tool, support the latest and greatest framework? Tomorrow there is a new version of Java. How long will it take until my static tool can support this? I hear this, sadly, I hear that a lot when I speak with potential customers mostly. We have an executive order to automate security scanning for all our applications by, let's say, Q3. Usually I come back and ask, okay, sure, we can do that. What's next? What are you going to do with the scan results? How are you going to handle them? And sadly, the answer sometimes is, we don't know. It wasn't part of the initiative. We need to automate the security testing. Surprise, some of the customers actually succeed in doing that. And you can see they run scans every day, a couple of times a day, but no one is looking at those results, so they're not getting any better. The number of vulnerabilities, the number of security defects in their application just grows. It never goes down. Make sure that you focus on the remediation, not on the testing themselves. Up to this point, I think I was pretty neutral, not marketing my own product, but I really wanted to let you know how are we handling, as a vendor, with a tool, how we handle those two problems that I mentioned just a second ago. Regarding false positive, regarding the noisiness, and regarding the false negative, the missing of the coverage of the application. So being IBM, we have a lot of knowledge about cognitive, about machine learning, and we harness those capabilities in our solution. So the first one, and you can hear about it later in one of the think tanks, intelligent code analytics. This is a cognitive capability that allows us to actually follow any API call that goes out of your application. Any method that is invoked from a third party, we can follow it because of this cognitive capability. And we have machine learning, intelligent finding analytics that takes a gigantic amount of results. The scan results can be thousands, can be hundreds of thousands sometimes, and without the need to have someone triage and filter, within seconds, intelligent finding analytics can reduce that to a subset, to the gold out of all the mud. It was trained by our expert, and it's maintained and trained over and over in order to improve and in order to find those gold findings out of the mess. Now, I mentioned earlier in speed that complexity and the time it takes to fix a problem is also something you need to consider. And we have fix groups, which allows you, we tell the customer, go to this place and fix there, because this is how you can fix multiple vulnerabilities in one place. I won't say that I'm the only vendor. I'm just saying that this is how we are handling it. I wanted to share from our point of view. No coverage. You need to remember the whole goal of what we just mentioned. Anatoly said, 24% of the vulnerabilities that are detected are not being fixed. 54% can actually be detected during the automated testing stage of development. Coverage is important. Our goal in coverage is to find and fix as many vulnerabilities as we can during the development stage. But what will happen if you scan all your applications and you use all the tools? You will find a lot of vulnerabilities. You need to make sure, as a security person working with development, you need to make sure also not to overwhelm them with the number of results that they need to handle, because then they will push back. And without working hand in hand with the development organization, you won't get anything. So how can you not overwhelm them? You're using policies. Traditionally, security policies were only in the hands of the InfoSec team. They were defining the gates. But as was just mentioned, in DevOps, it's hard to put hard gates because the development team will push anyway sometimes. They have daily push, they have weekly push, sometimes a couple of times a day. We know of companies that push new versions many times a day. So you need to have policies that are agreeable by the development organization also. I did a matrix here of different kind of policies, but the idea here is that you can work together, security and developers, hand in hand, not like this, and define the policy that fits you best. Maybe it's based on severity. I'm not going to push any version, any new code if it has new severity, new high severity. Maybe I'm not allowing any new vulnerability. Or it can be the OWASP and SANS. And it can be, of course, based on the industry that I'm in. I mentioned all those automated tools, right? All the automated testing. But as smart as the automated tool will be, it can be the best in breed in everything. It can be our solution, which is perfect, but it's automated. And automation will not replace people. I'm sorry if I'm offending anyone from the AI side, but people are important. There are business logic in the application. There are areas that you have to have a person analyzing, trying multiple tools, taking results from one tool, applying them in another tool, doing some research behind, speaking with the developers and with the user, understand how the application works, and then this person is the penetration tester. At the end of the penetration testing, the penetration tester will provide you with a report with all the vulnerabilities. It will sit and explain those and explain what is the risk, what is the application, and how to fix them. Make sure that you are using penetration testing. Of course, it's expensive. It takes time, so you are not going to do it as part of the cycle of the DevOps, but you need to do it periodically, especially on your high critical applications. Thank you.
Great, Dan. So Eitan's covered a great deal of grounds in terms of testing, right? We have the design development, and then we have the testing to validate that from the security perspective, those controls, those requirements have been implemented correctly. As Eitan correctly pointed out, one of the challenges historically has been immense rates of false positives, right? Just absolutely unmanageable amounts of false positives information, or maybe information that's not a false positive but is irrelevant to some extent. Harnessing the power of cognitive, harnessing the power of artificial intelligence, machine learning, and automation helps you from the testing side to ensure that you have consistently secured applications, to make sure that you have consistent application of those controls and requirements to ensure that the applications stand up in the real world. Now, one other area that I wanted to make sure we absolutely bring up and include in this conversation is feedback loops. Mentioned very early on, communications, collaboration, transparency are essential. Now, when it comes to feedback loops, a lot of times you have organizations that have development that's siloed from QA testing, that's siloed from BAs, that's siloed from project management. That cannot exist in the world of DevOps. And if those silos do exist, new communication paths need to be established to ensure that things like, for example, penetration testing outcomes not only lead to remediation of those findings or those issues, but also lead to enhancements in the requirements gathering to make sure that the root causes of those weaknesses, those defects, are not only addressed, but are also prevented in the future. Things like threat modeling outcome. We need to understand how these applications can be attacked, not only so that we can build the right controls and the right requirements to actually secure them in the production environment, but we can also pass those threat models over to the pen test group, for example, to specifically test the business logic, apply human level of logic to ensure that those non-functional requirements have been met appropriately. These are just examples, but at the end of the day, it comes down to the right tooling. It comes down to the tooling that enhances your ability to do things quickly. You need the right tool for the job. Otherwise, you will not be able to do it quickly. You need the right level of communications. Otherwise, your one end will not talk to the other end, leading to failures in the process. And at the end of the day, DevSecOps is achievable, but it cannot be achieved without the right resources, without the investments into the people that are making it a reality. The developers, the BAs, everybody must be trained, processes must be well-defined. But again, the communication, the transparency, collaboration, those pieces are absolutely essential. So with that, we are just at our time. I did want to summarize that the whole concept of DevOps and DevSecOps is it takes a village. It's not a one-team job. Everybody must be empowered. Everybody must be responsible and accountable for their role in the development process. With that, we do welcome you to reach out to us. We're going to be actually at one of the think tank sessions. Eitan, do you remember which one? Is it C?
I think, yeah.
OK, so we're going to be at Think Tank C. Eitan and I are both fairly easy to spot due to our fancy haircuts. So if you have questions, please don't hesitate to come up to us. Ask us anything. Try to stomp us if you can. And if we can't answer something, we'll certainly get you an answer. But again, your time is much appreciated. Reach out to us, talk to us, and thank you again for being here, and we hope you enjoy the rest of your conference.